Hello, today we are going to talk about motion under gravity. So far we have learned or studied or even solved problems involving horizontal motion in one dimension. But now we are going to study motion under gravity. So as we know, if you throw this marker upwards, it comes down. Why? Gravity attracts it downwards. So gravity makes something come down, and so all things that have mass is susceptible to gravity. So we can say gravity actually causes objects that have mass to accelerate downwards. This acceleration due to gravity, which makes objects come back down, is constant, and we can denote it, and usually we do denote it in physics with g. Small g refers to acceleration due to gravity, which has a constant value of 9.8 meters per second squared. This value is constant near the Earth's surface. So if you go somewhere on Mars, this gravity, acceleration due to gravity, would be different. If you go to the moon, it's different. So this is only valid for near the Earth's surface. So since the acceleration due to gravity is constant, this means that our 5 equations that we learned, the kinematic equations, they are valid for vertical motion under gravity. And hence, we are going to use those 5 equations to solve problems for objects moving in the vertical plane. Let's look at an example. So here we have a question that reads, a skydiver is free falling at a speed of 5 meters per second. Free falling, apart from being an awesome Tom Petty song, is actually referring to anything that falls under gravity. Okay? So we know that due to Earth's gravitational influence, the skydiver is free falling at 5 meters a second. Okay? So free falling speed is 5 meters per second. The question asks, what is the skydiver's speed after falling a further 20 meters? So speed is also our target variable, the final speed. Okay? And the skydiver falls 20 meters. Let's solve this. Alright, so like any other physics problem, the first step is always to draw a very basic, simple diagram. Choose an axis. I am choosing the vertical axis going up to be positive y. Okay, so anything that is directed upwards, I am choosing to be positive. I could have chosen downwards to be positive. Okay, now I am modeling the skydiver as a small ball falling under the influence of gravity, free falling. Let's say the fall, as per the question, is 20 meters. So the diver's motion started from here. So we say the initial time is 0, and I stopped recording the motion for however much long it needed to cover a distance of 20 meters downwards. And I know that there is a constant gravitational acceleration due to gravity. Now let's note down the variables in a much more regular fashion. What do we have? We have Vi given to us. This is 5 meters per second. But remember, we are noting down vectors, even though I'm not using the arrow. It's implicit that we always deal with vectors in these problems. So a speed of 5 meters per second, but the skydiver was free falling. So the direction is given to you implicitly. Falling means you can only fall downwards. So anything that goes downward has to be negative according to my chosen axis. Okay, because I used upwards to be positive. What else do we have? Do we have the final velocity? No, we don't. We actually want to find the final velocity. So we want to find the speed of the skydiver after falling 20 meters. Okay, so this is our target variable. What else do we have? We have the displacement given to us. The skydiver falls further 20 meters from the start. So the start was here, so I can define this to be the start of my y-axis. So I can define this point right here to be my origin of the motion, and from there the skydiver falls downwards. Since upward is positive, the displacement is negative 20 meters. Alright, and we also know that acceleration due to gravity is g downwards, which means a negative sign, g meters per second squared. Okay, we also don't know delta t because we don't know tf. Ti is 0, so we don't know what tf is. Alright, so we have vi, we want to find vf, we have delta x, we have a. So we have 3 variables. We want to find the fourth, which is final speed. So we need an equation that has the target variable in it. So what are those equations? First equation has vf, second equation has vf, fourth equation has vf, fifth equation has vf. Now we want to choose the equation that has all of these 3 other known variables. Let's look at the first one. Vi plus a delta t. We know Vi, we know a, but unfortunately we don't know delta t, so this won't come to any help. Let's look at number 2. We know delta x, we know Vi, we want to find Vf, but we don't know delta t, so disregard this equation. Similarly, delta t is also in equation 4, so we can't use equation 4. So we are only left with equation 5 that we can use. Okay, so use equation 5. Vf squared equals Vi squared plus 2a delta x. We want to find Vf, so Vf squared is equal to, what is Vi? Vi is negative 5, so negative 5 squared plus 2. A is negative g, g is 9.8, so negative 9.8 times delta x. Delta x is negative 20. So what is Vf squared? Vf squared is 25. Minus minus is a plus. 25 plus 2 times 9.8 times 20 is 392. So we square root both sides to get Vf. So remember, when you square root, you always have plus and minus both solutions, because you're actually having 2 solutions for a square, 3 solutions for a cubed. So one solution is plus, one solution is minus. Okay, so which one to choose? Let's see. So 25 plus 392, square root of that gives us plus minus 20.4 meters per second. Now if you are worried about the velocity, then we look at the skydiver's motion. The skydiver is going down, so the velocity is still negative even at that point. So if the question asks for velocity, our answer would be negative 20.4 meters per second. However, what is the skydiver's speed? The question asks. So we are looking for the magnitude of velocity. Magnitude makes this plus and minus ambiguity to go away, so that we always have a positive definite answer. So this is the speed. Let's look at another example. Here the question reads, Polly and Sam are playing catch. Polly throws the ball straight up with a speed of 15 meters per second. Polly throws straight up with a speed of 15 meters per second. The ball rises and returns to the same height as it was thrown by Polly, and Sam catches it. Okay, so we are actually assuming that Polly and Sam are of the same height. The first question is, draw the position time or xt graph for the scenario described. Okay, so this is actually application of motion graph concept into our gravitational motion. All right, so what do we have? We have given that Polly throws the ball straight up. Okay, so let's draw a very simplified diagram. So let's say here is Polly. She throws the ball straight up. It goes up, then it reaches a maximum point, right? So anything you throw up has to reach a maximum point, then it comes back down. So before it comes back down, you know that it has achieved that maximum height. So the ball reaches a maximum height before falling back down to the same height into Sam's hand. Okay, so this is the scenario being described here, and the upward initial velocity, if upward is positive, initial velocity is 5 meters per second, positive. Okay, and we want to draw the position time graph for this situation. All right, so as I said in the previous lecture, first we will draw out the relevant axes. The relevant axis in this case is position and time. So let's call it yt, because we are describing vertical motion. So in the vertical axis we have y, in the horizontal axis we have time, like before. Y is in meters, time is in seconds. Okay, this is the origin of the coordinate system. Now, what is the trajectory? It goes up. So when it's going up, you have to remember that anything that's moving in the vertical plane experiences acceleration due to gravity. Okay, so anything that goes up is being slowed down by gravity because gravity pulls it down. So gravity makes it accelerate downwards as it tries to go up. So at every moment it goes up, it is actually slowing down under the influence of gravity. So then what happens to the position time graph is, it starts out steep but then flattens out. Why is it flattening out? Because if you remember, the gradient of position time graph is velocity, and since gravity is making the ball accelerate downward, the velocity as it's going up is actually decreasing. So the gradient of this curve is flattening out. And why is this a curve in the first place? Because as we know, for a straight line graph, the velocity, the slope needs to be constant, and constant velocity means zero acceleration. But anything that's moving in the vertical plane is always being accelerated by gravity. That's why anything that's moving in the vertical plane must have a curved xt graph or yt graph. Okay, so it flattens out until it reaches its maximum height and then turns back down again. So then it will turn back down and reach the same height as it was before. So the displacement is actually zero because it went up a height, it came back down the same height. So plus minus 0. Okay, so this is the position time graph for the scenario. Now, if we want to note some important features of this graph, we can write down some specifics. So this part of the motion is the ball going up. Okay, so the tangent at each point is flattening out as gravity accelerates it downwards. At this point is maximum height. Okay, at maximum height, if you draw a tangent, you see that it's completely horizontal. As we have learned before, horizontal lines or horizontal tangents, horizontal straight lines have a gradient or slope of 0. That means at maximum height, the velocity of the ball is 0. This is true for not only the ball but anything moving in the vertical plane. And when an object reaches maximum height moving under gravity, there the velocity is momentarily 0 before it comes back down again. So acceleration, the gravity never stops making things accelerate, but at maximum height the velocity momentarily goes to 0, the acceleration doesn't. And this part after surpassing the maximum height is the ball coming down. Okay, here if you draw tangents, you would see the tangent is positive but flattening out. Okay, so velocity is still positive but decreasing. So in this part of the motion you are actually decelerating. But in this part of the motion, if you draw out a tangent, you would see that the tangent is sloped like this, hence it is negative. Tangent is negative and it's getting steeper every moment it goes down. Why? Because now it is actually moving with gravity, so the speed is increasing but in the negative direction. So in this part you have what is called, we learned, to be negative acceleration. Okay, so the speed is increasing but in the negative coordinate direction. The second part wants us to draw the velocity time graph for the current situation. All right, so as we have done previously in the previous lecture, we'll use whatever information we have from the position time graph to draw out a velocity time graph. So as we have so far discussed, that before reaching the maximum height, the velocity is decreasing as the ball moves upwards. So the first part of the journey is a deceleration, and beyond the maximum height, the velocity is increasing in the negative direction. That means at the beginning of the motion, if you draw a tangent to the position time graph and then compare that tangent to another tangent afterwards, you would see that the tangents are flattening out as you go towards the maximum height, which means that the velocity started off at a high as Polly threw the ball upwards, then started decreasing as it continued to reach maximum height. So the relevant axis is V and T. Ball starting from Polly's hand at V1, which is a high velocity, let's say, whatever, we don't know the exact value, and keeps decreasing over time until it reaches maximum height when the velocity momentarily goes to 0. As soon as it leaves the maximum height and turns back down, the velocity is increasing, right? If you draw tangents, you'll see that the tangents are actually getting steeper as the ball comes down. That means velocity is increasing in the negative direction. So we have velocity continuing from here but in the negative V direction. So V upward is positive, anything downward is negative. and this is 0. Okay, so here the ball reached its maximum height where it momentarily went to rest. Beyond it, the ball kept accelerating downward, and here the ball returns to Sam's hand. Okay, here it left Polly's hand. At this point, the ball returns to Sam's hand. Okay, the third part of the question now asks me to draw an acceleration time graph, or an AT graph. So we know that acceleration in this vertical motion or any other motion under gravity is constant at negative 9.8 meters per second with respect to the positive chosen upwards. So our relevant axis is A and T, and we end up with an acceleration of negative 9.8. This is constant throughout. Okay, this is a feature for motion under gravity. All right, so then question 4 asks me to find the maximum height reached. Okay, so how do we do that? Well, again, height is nothing but a kinematic variable that we know as displacement, delta x or delta y. So it's common to use y's in vertical motion and x in horizontal motion. Okay, so we'll try to stick by it. So in this problem we'll use y for everything instead of x. All right, so to find maximum height, we already had a diagram with the axis upwards set as positive, y going positive upward, and the ball is launched up with a speed of 15 meters per second, as far as I can remember. Yes, 15 meters per second, and then it reaches a maximum height. Let's call it y equals h. Okay, before returning back to ground. And also we know that throughout its motion there is Earth's gravitational acceleration causing it to come back down. So what are the information or kinematic variables that we know and which is our target? We know Vi is 15 meters per second, and it is positive because Polly launched it up. Then at maximum height, as we have just seen when drawing out the motion graphs, at maximum height the velocity goes to 0 before coming back down again. So this is our final point. So this is our initial point, so Ti is 0, and this is our T final. All right, we don't know what T final is, but this is our final point for this part of the problem because it asks us to find maximum height. So it is sufficient to consider the first part of the motion from when it left Polly's hand to when it reached maximum height, because that is what we are interested in. So Vf at that maximum height is 0. Okay, then also we know that acceleration is a constant negative g meters per second squared. What else? Do we know anything else? And we want to find out the displacement, that is the maximum height we want to find. So this is our target variable, and we know these three variables, Vi, Vf and A. So we have to use an equation with delta x or delta y in it first of all. So we can't use 1, we can use 2, we can use 3, we can use 4, we can use 5. But what is the equation that has Vi, Vf and A? We cannot use 2 because it has delta t, we don't know delta t. Again, we don't know delta t for 3, we don't know delta t for 4. So the only equation left to us is equation 5. So we use equation 5. So Vf squared is equal to Vi squared plus 2a delta y in this case. So Vf is 0 at maximum height. Vi is 15 squared plus 2 times negative g, which is 9.8, times, we call it h, and h is positive. Why? Because displacement is up and up is positive, so it goes up to a height h, so that's why h is positive. So we can do some algebra. Bring 15 squared on this side, that is, subtract 15 squared from both sides. So we have 0 minus 15 squared, and 15 squared minus this whole thing on this side tells me that 15 squared is no longer on this side. So here we have 2 times minus 9.8 times h. Okay, so we are left with negative 225 is on the left hand side, and 2 times 9.8, negative 196 h. The negatives cancel from both sides, and h is when you divide both sides by 196. So h comes out to be 225 divided by 196, 11.5 meters. This is the maximum height reached by the ball. Okay, so now the question wants me to find how long does the ball take to reach the maximum height h that we just calculated. So we already have the diagram from the previous step. So let's note down what are the relevant kinematic variables that we need to solve for time. So how long it takes, that means we're dealing with time, right? So what do we have? We know again Vi is 15 meters per second. We know that at maximum height Vf is 0 meters per second. We know acceleration is nothing but negative g, or negative 9.8 meters per second squared. We don't know what time is, and we know the height that we just calculated, the maximum height, is 11.5 meters. All right, so we want to use this height to find delta t. All right, so what is the equation that has height, time, and two of these available variables? So let's use equation 3. What is equation 3? Well, we have delta y equals Vi times delta t plus 1/2 a delta t squared. And let's represent delta t with t from now on. Delta y is h, which is 11.5. Vi is 15 times t plus 1/2 times negative 9.8 times t squared. So 11.5 equals 15t minus 4.9 t squared. Let's rearrange this equation so that everything is on one side of the equation. So let's bring these two terms to the left hand side. First, let's bring negative 4.9 t squared to this side. That means negative becomes a positive when you change sides, since you're adding 4.9 to both sides. So we have 4.9 t squared. Similarly, bring 15t on the left hand side, becomes minus 15t, and 11.5 was here from the beginning, so it remains 11.5 equals 0. From here we want to find what t is. Now this is a quadratic equation. A quadratic equation is when the variable that you're solving for has powers of 2. So there are a number of ways to solve quadratic equations, but the simplest is to use the quadratic formula because it works all the time. What is the quadratic formula? The quadratic formula is for any general quadratic equation. It doesn't have to be t that you're solving for. Let's say we have equation ax squared plus bx plus c equals 0. So remember, the equation has to be on like this. So every term should be on the left hand side of the equation, the other side must be 0. Okay, so for this form of the equation, x can be solved for using the formula x equals negative b plus minus square root b squared minus 4 times a times c over 2 times a, where a, b and c are coefficients of x squared, b and c respectively. Now let's compare this equation to that equation. What is the coefficient of the squared term? Here the square is t squared, so a is 4.9. 4.9. b is negative 15, the coefficient of t, and c is positive 11.5. Okay, so t can be solved for using that equation and these coefficients. So t equals negative b, so negative of negative 15 plus minus square root b squared negative 15 squared minus 4 times a 4.9 times c 11.5 divided by 2 times a 4.9. So if we do that, we end up with t equals 15 plus minus square root 225.4 over 9.8. Square root of 225.4 is 15.013. So we can see it is slightly larger than 15, which means if you subtract this from 15, then you would get a negative answer. Time cannot be negative. Time is absolutely positive. So we disregard the negative piece of the solution and we only keep t equals 15 plus 15.013 over 9.8, and we end up with a value of 3.06 seconds. So this is how long it took for the ball to reach maximum height. I hope this detailed example actually made kinematics a lot simpler.